Hello friends, my name is Tosif Khan from ICT branch Marwadi University. Today's my topic name is direct sequence spread spectrum. Let us understand this topic. First we need to understand what is spread spectrum. It is the technique for expanding signal bandwidth. Spread spectrum is a technique that intentionally broadens signal bandwidth across a wide frequency range, enhancing security, noise resistance, and reducing the risk of jamming in communication system. Jamming is the act of blocking the wireless signals. It makes the device impossible to send or receive the data. What is Dsss? It is a direct sequence spread spectrum, the technique where the data signal is multiplied by a pseudo-random noise sequence. It is a deterministic stream of ones and zeros, looks random but repeats after a very long period. This process spreads the signal's bandwidth, enhancing security and resistance to interference. The receiver utilizes the same PN code to accurately recover the transmitted data. Let us understand this with an animation video. There is a slice of a bread and we are spreading the butter. Think this like butter represents a narrowband signal, which is the original signal. We are spreading the butter on the bread. Simply this thing occurs in Dsss, data multiplied across much wider frequency band.
Direct sequence spread spectrum. The concentrated butter is our narrow signal.
PN sequence. The pseudo noise sequence appears random but is predictable. It consists of a high rate series of ones and zeros, where the length determines the spreading factor. Synchronization requires the receiver to use the same PN code to correctly decode the transmitted data. Chip rate and spreading. In direct sequence spread spectrum, each bit of the PN sequence is referred to as a chip. The PN code operates at a significantly higher rate than the data bits, resulting in a spreading factor that enhances security and noise immunity for signal transmission. Dsss time domain concept. In this concept, the original data bit, either a 1 or a 0, is multiplied by a pseudo-random noise code. This process transforms the narrow data signal into wider spread signal, resulting in cleaner and more secure transmission of information across communication channels. Frequency domain. In the frequency domain, narrowband data is spread into a larger bandwidth, distributing power across a wider spectrum. This technique enhances resistance to noise and interference, making jamming more difficult. The broader signal allows for improved communication reliability in various environments. Advantages of DSSS is noise resistance. It is very resistant to various noise types. Security, it requires a PN code for decoding signals. Jamming resistance, it is hard to jam compared to other methods. Disadvantages of DSSS. Bandwidth. DSS requires a large amount of bandwidth for transmission. Complexity, the system involves complex transmitter and receiver designs. Synchronization, precise synchronization is needed for proper data recovery. Real life applications of DSSS is it is used in Wi-Fi For secure wireless communication standards, it is used in GPS, relies on Dsss for accurate location tracking signals. CDMA employs to enhance mobile communication reliability. Thank you.